Welcome to Math with Wong. Today we're going to look at number 9 of the May 2024 paper 2. It's the last question on the exam. As you can see, it's something to do with trigonometry. The good news here is they've labeled the diagram and give you all the information that's given. The size of the wall, the angle, and one of the side length. Now, if you take a look at the question, I'd be kind of give you a hint here. Whenever they say two possible answers, two possible angles, you're given one angle and two side length. That's a typical ambiguous case question. It's a sine law. You're given an angle and you have two side lengths, and the question is asking you two possible sizes, right? Which kind of like, giving you the hint and say, hey, this is a ambiguous case. Another thing that you have to pay attention to, the answer must be in degrees. So you need to, if you're using TI-84, change the mode to degrees, or else your answer is not going to be right. So we have to set up our cosine law. We have 25 and 28 degrees. That's a pair. 50 degrees is going to go with, 50 meters is going to go with angle B. So we're going to set up sine law. Sine B over 50 is equal to sine 28 over 25. Solving for angle B. Punch in the calculator, angle B, I am getting 69.8748 degrees. That's the first answer. The second answer would be 180, subtract that, which is going to give me a 110.125, right? Okay. Two possible angle of OAB. So OAB though is this angle. The question is asking us to find OAB, which is this angle. So to find angle A1, first case is going to be 180, take away 28, take away 69.8748, right? Round off to 3 sig fig. And I'm getting 82.1 degrees. A2 is going to be 180 minus 28 minus 110.125. That's going to be round off to 3 sig fig, 41.9 degrees. Okay. So that's part A1. Find the two possible angles of angle OAB. It says part A2, hence find the two possible areas of the triangular field. So to find the area of a triangle, that's what part B is focusing on. We need to use the formula. Formula of area of a triangle would be half AB sine C. Basically is two sides and a contained angle. So when we go back to this, we want 50 and 25 and then angle A, which we calculated. So the area of the first triangle is going to be half A, which is 50 and then 25. And sine of angle A, which we calculated, was 41.9. That's the acute angle. So what I need, I'm just going to write the answer down. Actually, sine 82.1. I'm probably not going to round it up to 0.1 and write down everything I have. So it's what? 1. I wrote it down somewhere. I don't want to round it off because then my answer is going to be off too much. It's 82.1251. The second area would be half AB sine C, and it's 41.8748. Punch in the calculator. I'm going to be able to find the area. The first one is going to be around up to 3 sig fig, 619 meters square. And the second case, if I put in the calculator here and round it off to 3 sig fig, I should be getting 417. Okay, so it's this area of a triangle. Half AB sine C. If you want to use the 28 degrees, then you're going to use, you have to find this length. Right, so the easiest would be use 25 and 50 and then use the angle A that you just calculated. Half AB sine C. Okay, next part of the question. They're adding a fence 10 meters long between the walls. So you can see how C and D here is 10 meters. The small triangular field OCD has an area of 60 meters square. It says let the distance OC be Y. No, sorry, OC be X. This is OC. And OD be Y. So this is cosine law. You see how you have 3 sides and an angle. This two kind of like goes together, right? So setting up cosine law, 10 square would equal to x square plus y square minus 2xy cosine 28 degrees. That would be, yep. Okay, and then area is 60. The area of a triangle, which is 60, is equal to half AB sine C. So half AB sine C. So if I can substitute xy, you see how there's an xy here and an xy over there. If I can rearrange the equation and substitute xy, I'm going to be able to make it look like that. Okay, so first of all, I'm going to take the cosine law, which is and rearrange it so that you can see x squared plus y squared is going to be 110 squared plus 2 times xy cosine 28 degrees. Okay. Now, I'm going to isolate xy using this. So xy is going to, now if I'm going to bring it to the other side, it's easier for you to see. Then I'm going to bring the half over, so it's going to be 120, and I'm going to be divided by the sine 28. Okay, so I'm going to be substituting this 120 over sine 28 degrees in for xy. So this is going to equal to 100 plus 2 times 120 over sine 28 degrees. And you can see that's how you get the 240. Right? And then what do you have? Well, you have a cosine 28 over a sine 28. Cosine over sine is equal to cotangent. Cotangent is equal to 1 over tangent. So this is equal to 1 over tangent 28. So therefore, 100 plus 240 divided by tangent 28 degrees. So now we have shown that x squared plus y squared is equal to 100 plus 240 over tangent 28. Lastly, what are we asked to solve? We're asked to solve for the two answers for OC. OC is x, so we're solving for x. So here we can isolate and solving for the x. You can even probably using a graphing calculator, isolating this two and kind of like using a graphing calculator to find the point of intersection and solving for x. That's probably going to be the fastest way of solving this. If not, you would have to do a substitution, right? Sub into this equation here. So I'm going to come back to this little part. So let's say we want to solve it by hand, or you probably need to use the calculator anyways. So I'm going to rewrite it. I'm going to take the cosine law here, right? So 10 squared, 100 is equal to x squared plus y squared minus 2xy cosine 28 degrees. Now, we already know what xy is equal to and has simplified it, right? Xy is equal to 120 over sine 28. So we already have this part. So I'm going to use this equation instead because it's faster. So that becomes 240 over tangent 28. Okay, so here I can then isolate y by itself and substitute y into the equation. Right? So how do I isolate y? Well, we're going to come here. See, you have the 60 is equal to half xy cosine 28. I'm isolating y, so I'm going to bring the 2 over. So that's going to be 120 divided by x times sine 28 degrees. That's going to be my y. Okay, so I'm going to sub that in for my y square. So 100 is equal to x squared plus bracket 120 over sine 28 degrees multiplied by x, close bracket, square, minus 240 over tangent 28 degrees. Okay, this looks complicated. I mean, I can punch in the calculator and solve by hand, but it's faster to using graphing calculator at this point. So this is my y1, this is my y2. I'm going to do my second trace 5. Just make sure you enter into the calculator carefully. Make sure the mode, as I said, right, should be in degrees because you're talking about degrees here, right? And then you can find the point of intersection. So using the graphing calculator, I got 2 x values, round off to 3 sig fig. X is 13.1 or x is 19.5. Okay, so that's the 2 values of OC. 13.1 meters and 19.5 meters. Basically, the last little part, you have those 2 equations. 2 equations, 2 unknown. You're trying to solve for the x value in this case. Okay, so that's the last question. We're focusing on a ambiguous case of a sine law. You have area of a triangle. You have a cosine law, another area of a triangle, a little bit more work in terms of a range and algebra, and then solving using a graphing calculator. Okay, all right, great. Thank you for watching.